And that brings us a bit closer to the present. Those developments allowed us to do something that would have been unthinkable 1,000 years ago, and that's to put people and robots in space. And that was the birth of the space age, where we started launching rockets, satellites, dog, chimp, and eventually other humans into space, sending people to the moon and robots to Mars, and a car into space for some reason, playing David Bowie. And now satellites are a critical industry. The resources they provide in terms of imaging the Earth's surface and the data they beam back are crucial for resource management, hazard planning and mitigation, assessing environmental impact. And one of the keystone data sets for the evidence of anthropogenic climate change is given to us by satellite imagery. And it was really rapid, largely because of a space race between the US and the USSR. So it started with Sputnik, which was a Russian or USSR probe, just basically a ball with an antenna. Then we jumped forward to the Apollo missions and sending men to the moon to walk about on its surface. And it's just kind of this epic piece of engineering, science, equipment. The technological developments that we got from just doing this are astronomical. There's a saying that every dollar we spent on the space race and the Apollo missions, $14 came back into the American economy, which is just bonkers.
More forward, drift into the right a little. Right, down a half. Contact right. Okay, engine stop. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
At the foot of the ladder, the LEM footbeds are only depressed in the surface about 1 or 2 inches. Although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
Now that statement is embedded in Earth's history now. What I'd like to hope you noticed is before the iconic one small step for man, he actually gave a very detailed description of the soil. So actually the first words that were said on the moon was a description of the geology of the moon, just to show how well embedded Earth science is. We've got since obviously even better at exploring space with the space shuttle, which was the first kind of reusable rocket. It allowed us to put really big kind of satellites into orbit, do some crazy stuff like repair satellites in orbit, which was something you never thought would be possible before, because once it's up, it's up. Whereas with the space shuttle, we were able to go and fix things like the Hubble Space Telescope. And all this technological development has allowed us to send up stuff and build amazing things like the International Space Station and bring us all closer together. So the International Space Station is this amazing construct that's orbiting the Earth every 90 minutes, built by essentially every nation on Earth, been colonized by every spacefaring nation on Earth, and there's always a human presence in space. And now the game changes. In the last few years, we've seen huge advances in rocketry, particularly SpaceX Falcon Heavy rocket, well, any SpaceX rocket really, which is essentially doing the maths and going, the most inefficient thing about space flight is the first stage gets destroyed completely. You lose it. And so Elon Musk and SpaceX had this bonkers idea that you could maybe recover it and get the first stage to land safely so you could reuse it. And everyone thought they were mad, and they've only gone and done it, which is amazing. And this is going to revolutionize how we do space travel and make it even more accessible to everyone. and for the benefit of everyone. I want to jump back to Apollo because there was a really important thing that happened in that period, which kind of goes a bit unsung in the sort of space race, and that's this image. This is called Earthrise. It was taken by Apollo 8 as they were orbiting the moon, and as they were coming round from the far side, they took a snapshot of the Earth as they saw it back. And this is possibly the most important image that has ever been taken, because this was the first time we'd seen our own planet from the surface or from the orbit of another world. And it kind of gave us an indication of our significance in the darkness of space. We're just this tiny pale blue dot in this against a backdrop of stars. And this kind of put into the human psyche this idea that Earth is special, Earth is precious, and we want to look after it. And so the birth of the environmental movement and environmental science, and in fact the first Earth Day celebration, happened the year after this image was taken. So it's an incredibly important image, and one that I hope will drive us into solving the climate crisis we're facing. Continuing our journey of Earth science and us, from the 1970s to the present, we've basically entered the digital age. We've been able to start extracting rare precious metals from the Earth, and these have fueled a technological revolution for electrical systems and computer systems, being able to miniaturize them so they aren't just the property of big governments, but I have now in my pocket a computer with more power than NASA used to send people to the moon. This has provided a boom in intelligence and information, and accessibility to information. Information is now available to everybody, so it's been a great leveler in that regard. But there's been some huge titanic changes that have happened during that period, like social media, the World Wide Web, all these things, and how we navigate this new digital world is something we're learning as we speak. And with all this stuff comes challenges, and we've got to be careful that we don't overutilize. We've got to eventually move to a sustainable regime. There's lessons from the past here. If you look at Easter Island, it's an island where the inhabitants built a bunch of stone heads. And they really liked these stone heads and started cutting down all their trees to build more stone heads. However, their trees were linked to their food supply. And so the more trees they cut down, the less food they got. Yeah, turns out the heads weren't very tasty, so the humans on the island either left or starved to death. And right now, that's not an option for us. We can't leave the Earth. We're stuck here. We can't do what the Easter Islanders did and just move somewhere else. We need to take care of this special planet A because there is no planet B. And kind of what I'm going on about here is this graph, which is the hockey stick. It's essentially a measure of carbon dioxide emissions and average global temperatures over time, going back a few thousand years. Now, so as you can see, it kind of bubbles along, goes up and down a bit, but it kind of remains roughly constant until you hit around the 1900s, and then boom, temperature starts skyrocketing, and alongside carbon dioxide emissions. And what this has driven this is we are essentially victims of our own success. Our ability to provide riches and technology by using Earth's resources and importantly burning fossil fuels has led to rampant financial inequality and societal inequality. And there's huge demand now for rapidly diminishing resources because the Earth isn't infinite. And so we're learning kind of the hard way right now that infinite growth that is required of regimes like capitalism don't really work when you have a finite system like the Earth. And that's leading to this warming effect, which we call anthropogenic climate change. And so all of this is a product of our dependency on fossil fuels and mineral resources. And that's been facilitated by and large by our advances in the earth science discipline. The more we've been able to learn about the earth system, the more we've been able to utilize Earth's resources. However, while earth science has certainly been one of the driving forces of these problems, it's also, bizarrely enough, the solution to all these problems, because the exact same skills and the exact same knowledge can be retargeted to go, okay, how do we make all this sustainable? How do we make all this green? How do we mitigate this change before it's too late? And that's where we're really at right now, with environmental science and earth science. We're not about digging stuff out of the ground unnecessarily. And if we do have to dig it out of the ground, we want to do it sustainably and greenly, as well as cleaning up and tidying up what we've generated. So producing, on average, a better world than when we left it. This has led to some quite ambitious, dramatic steps by organizations like the United Nations. They've set out a series of sustainable development goals that we want to hit with over the next few years. And they're from everything from like wiping out poverty completely. No one should be hungry. Everyone should have access to healthcare and a quality education. There should be equality in the genders. Everyone should have access to clean water and sanitation. Everyone should have affordable clean energy. Everyone should have the access to decent work, and the economy should be growing. Industry, innovation, and infrastructure should advance. Try and reduce any type of inequality between nations and between cultures and between societies and between people, and build sustainable cities and communities that can last for a lot of time rather than the boom and bust that we're currently seeing. And then tying that into responsible consumption and production of resources, taking severe and hard action in response to anthropogenic climate change to mitigate and reduce that back to pre-industrial levels, preserve life below water, preserve life on land, peace, justice, and strong institutions, and build a global partnership to support all these goals. Now, these are some really ambitious targets, really hard-hitting. If we can nail all these, the world will be in a substantially better place than it is right now. And what's really great is earth science is the key to solving all of them. Remember I showed you this poster from the Geological Society and all the careers you can go into. All the sustainable development goals that I just listed are hit by a career in geoscience and earth science and environmental science. So anything you do with this degree will help make the world a better place. So thanks very much for listening. I hope you now see how we are, as a society, as a civilization, as a species, intrinsically linked to our relationship with the earth and its resources and its environment. How without it we'd be nothing, and with it we can be something amazing. How our ability to, and then looking at the present, how our ability to utilize these resources are causing us problems right now that need immediate attention and immediate solutions. But from past experience, looking back at our record and looking at the earth science as a discipline, we can use it to develop the tools and the infrastructure and the outset and mindset to be able to address these really hard problems that we're currently facing and solve them and make the world a better place. Thanks very much.